Welcome back. We are now working on lesson 33, radian measure in angles. And this is a pretty important lesson for those of us taking geometry now. It begins here, but we'll see if we worked in Algebra 2, pre-calc and calculus. So a lot of things on radians. And the main thing, again, probably explained in the classroom video, is that we measure arcs not so much in degrees in real life, but in actual measurements of the circumference, or arcs, if you will, like pieces of the circumference. And so one way to show this, it would be in using radian measure. And remember, one radian is basically equal to the measure of the arc that is intercepted by the central angle. And so one radian is equal to the length of one radius. So that's where it comes from, the idea of a radius and a radian relate to each other. How many radii does the central angle open up? So here we have a situation where the radian measure is going to be the measure of the arc length divided by the measure of the radius. And so here the formula we are going to use is going to be simplified as theta is equal to S over R, where S is the arc length and R is the radius and theta is the angle measure. So it says here, question number 1, this diagram below, a circle is shown with particular radius and particular arc length. Determine the radian measure of the central angle. Express transfer in simplest terms apply when applicable. So here we go. Now, not every radian measure is going to be in terms of pi. So we see here for A, our angle measure theta is equal to the arc length, which this is S, is 6, and this is R, our radius is 4. So this would be 3 over 2 radians. That's the answer for number 1, or 1A in this case. For 1B, again, we label this as S, label this as R. Our angle measure, theta, is going to be 8 pi over 12, and we simplify that by dividing top and bottom by 4 to get 2 pi over 3 radians. And we don't have to write the whole word radians. You can abbreviate it as rad. So, okay. For part C and D. So for C, again, this will be S, the arc length, and this is R, the radius. So theta, the angle measure, is 5 pi over 10, and so therefore theta is equal to pi over 2 radians. And finally, for D, here we have, it looks like what we refer to as a reflex angle, an angle measure that's greater than 180, because we have a major arc. And so theta, our major arc S, is 34 feet, while the radius is 8. So we have 34 over 8. So theta is equal to, we can divide top and bottom by 2 to get 17 over 4 radians. And notice in this case that the the units are going to be the same, so we divide out, our units will divide out as well too, so we just get a radian measure. And so this is a full page of the work of question number 1. Okay, so we're kind of following a formula, if you will, but remember, it's not so much a formula that when we measure radians, it is really the ratio of the arc length divided by the radius. Okay. And it's a measure of the central angle, although we will be using the same concept later on when we break out of circles. Okay, so I'll make this full page again, and question 2. So Janine walks in a circular track whose radius is 60 meters. If she walks a total of 100 meters, so 100 meters, which of the following is the radian angle which rotates around the center of the track? So here we go. Let's kind of draw a diagram. Well, first off, I'm going to pop a point here as the center. And from there, we're going to expand our circle around that. So that's our center, and that's our circle. Okay. And so our radius here, let's draw a radius, and that'll be 60. And so here, the amount of the track that she walks is about 100. So no, let's see now. That's definitely more than one radius. Is it probably less than two radii? Because then you can estimate this too. So I'm not we're approximating this case, so it's not accurate, if you will. So this will be in this case 60 meters. 60 meters. All right, and our track will be 100 meters. Now keep in mind that a radian measure, and our theta in this case, so theta, break out this little measurement here. I'll be doing this quite a bit to fill in the theta. So here we go, insert. And so we're done with this. So here what we're going to do is, drag this here. This is the angle measure. Here we want to ask ourselves, okay, since the radian measure is how many radii does this person walk? If one radius is 60 and she walks 100, she's definitely going more than one radius. But since two radii is 120, it's going to be less than two radians. Again, because you're saying, well, how do we know this? It is going to be the arc length over the radii. And so the idea is that how many radii, that's what you want to think about. A radian is how many radii is the measure of the arc intercepted by the central angle. And so here we get theta is equal to 100 over 60. Now we simplify that, now the zeros divide out, so zeros divide out, and so now we have 5 over 3. So theta is equal to 5 over 3 radians, which is going to be choice 1. Okay, so again, angle measure, dealing with radians, how many radii is the measure of the arc intercepted by the central angle? Okay, now let's try number 3. Now, which circle has the greater radian rotation shown below? And so here we're going to look at first theta A. Our arc length is 11 inches, while our radius is 6, so we have 11 over 6. Okay, and for the angle measure theta B, here we have our arc length 20 pi and our radius 30. So we have 20 pi over 30. So now what we'll do is we'll try to get decimal values to kind of compare the two of them. And so here, break out a calculator. All right, okay, so stuff from last time, so clear this. And so we'll do 11 divided by 6. So 11 divided by 6. And so we're going to get 1.83 bar radians. Okay, so this is a 1.83 bar radians. Okay, and now we'll go to our second one, 20 pi divided by 30. Okay, so we do 20 and then pi divided by 30. Enter. We get 2.094. So about 2.094. Oops. So here we get, so theta B is approximately 2.094 radians. And we see in this case, the greater radian rotation would be theta B. So we'll say in this case, theta B, all right, theta B has, it's easier to type out the rest of this, has the greater radian rotation value. Because in this case, not because it's basically value-wise is a greater radian, meaning in this case the angle measure theta B is greater than theta B has a greater value than theta A. Okay, so this is how we compare them. Which basically you're looking for the theta values. Okay, and so This will end part one of our homework review. Again, it is a new way of measuring angles. First, we'll talk about the central angles and all, and then we'll probably branch out later on in other ways. So this is where when we look at a calculator, why we have two different angle measures, radian and degrees. Yes, radian measurement, it does become a very important way of measuring things. And actually, when you graph trig functions on your graphing calculator, you will have to graph in radian mode, okay? So just otherwise, everything is kind of messed up and also. Right, ladies and gentlemen, I hope this was helpful. I know this topic can be a little bit confusing, and I hope that you guys are watching the video, and I'm going to try to do a supplemental video for explaining this, hopefully to make it as clear as possible, as basic understanding as possible for you guys, because it's very important you guys know a radian measure. I thank you so much for watching the video. Hope it was helpful to you. Leave any comments or questions below in the comments section. If you found this video helpful, please leave a like. Appreciate that. And of course, subscribe if you have not subscribed to the channel yet. We thank you all for being able to just watch the video and hopefully learn. And take care of yourselves. See you in the next video.